Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome to another video. Today we'll discuss a problem. It's about the automatic return of a double acting cylinder. So I have three problems here, but the solution of this problem is different. So let's tackle the first one. So it says that indirect control of automatic return of a double acting cylinder and double solenoid. First, I need a double acting cylinder and a solenoid operated DCV. So here I have this double acting cylinder and I have a 5x2 DCV which is solenoid operated on both sides. Now let's do the electrical part. And I already discussed the direct and indirect control in this video. You should watch that. Okay, so now let's make some identification. Double acting cylinder will return to its initial position automatically. So at the final position, I need an identification or I have to give a limit switch there. I'm giving identification A1 and suppose the cylinder name is A. So this is the initial position of the cylinder and this is the final position of the cylinder, right? Now this is my push button PB1. This is my first relay coil K1 and this limit switch will sense K1 and give signal to this Y1 solenoid, and this Y1 solenoid will be linked to this left side of this 5x2 DCV. Okay. So when the cylinder extends to A1 position, then this limit switch will activate. So it will sense A1 and this relay K2 will get energized and activated. Because of that, this limit switch will sense that K2 and this solenoid will be energized. This solenoid Y2, and I will link this solenoid to the right side of this DCV. So this is the overall solution. Now let's see in the fluid sim software. So this is my pneumatical part. Now for the electrical one. Okay, so let's identify all of this. This is my push button PB1. This is my relay K1. This relay is K2. This solenoid is Y1. This solenoid is Y2. This limit switch will sense K1. This one will sense K2. And I have to make identification on the cylinder also. So actuating levels, unit is in millimeter, start position 100, end position is also 100. And this limit switch will sense A1. Watch this thing carefully. So this limit switch is sensing the end position of the cylinder. So this limit switch is physically present at the end of the cylinder. I discussed limit switch in pure pneumatic system in this video. The concept is same as that video, but this two limit switch is getting their signal from this relay coil. So these are not physically present near the cylinder. Okay, so now let's simulate. Starting pushing PB1. I also have to link the solenoid to this DCV. So this is Y1 and this one is Y2. Okay, so let's simulate. pushing PV1. See, let's see in single step. Okay, pushing PV1. See, K1 is getting energized. This limit switch is closed. Because of that, Y1 is energized, and for that, the left side of this 5 by 2 will get actuated. And when A1 position is reached, this limit switch is closed and K2 relay will get energized. This limit switch, which is sensing K2, will get closed also, and Y2 solenoid will get magnetized, and the right side of this 5 by 2 DCV will actuate. See, works perfectly. Now let's move to the next problem. Here the next problem states that automatic return of a double acting cylinder spring return. So the right side of this 5 by 2 DCV have to be a spring. Let's copy this. Okay, so I have to make a spring return on the right side. I already solved a spring return problem in the previous video. There I introduced the latching concept. I have to use that concept here also. So I'm going to apply the dominant off concept. If you haven't watched the latch concept video, please watch that. Otherwise, you won't understand what I'm about to do. Okay, so this is the solution. Now let's identify all of this. So this is my first push button PB1, and this is the limit switch. This limit switch is sensing A1, and this is my relay coil K1, and it is linked to these two limit switches K1 and K1, and this is my solenoid Y1. I'm telling you again, and this is the dominant off circuit. You can also use the dominant on if you like, but I prefer the dominant off more. So let me quickly tell you what will about to happen. When I close this PB1, then this K1 will get closed, a signal will get latched through here. So this K1 relay will still be energizing after I release this PB1 push button. So there will be always a connection. Now, when this cylinder moves to this A1 position, this limit switch will sense that and breaks this contact. So it will get open. So this whole circuit becomes inactive. And after that, this spring action will return the double acting cylinder to its initial position. Let's see in the fluid sim software. Okay, so I have this push button and let me connect all the components. And this limit switch will sense the end position of the double acting cylinder. So it will sense A1. So I exactly did what I showed you earlier. So now let's simulate. Start. Okay, let's go step by step. First, I'm pressing the push button. Now see what happens. See, a connection is made. K1 will get energized and this limit switch is closed. So Y1 will be energizing and the left side of this 5 by 2 DCB will actuate. The cylinder is moving to the extended position. The cylinder is now at the extended position. A1 is sensed. Because of that, this limit switch is open and this circuit gets deactivated. So after that, for this spring action, the right side of this 5 by 2 DCV will actuate and the cylinder will return to its initial position. So that's how the circuit works. Now let's tackle the third problem. Here it is saying that automatic return of a double acting cylinder using proximity switch. So I can solve this problem in two ways. First one is that The 5x2 DCB will be solenoid operated on both sides. And the second one is that the 5x2 DCB have a solenoid on the left side and a spring return on the right side. Let me show you both. So first will be solenoid operated on both sides. Let's copy this circuit. So the double-sided solenoid solution is very simple. I just have to change one part. Here in this limit switch, I just have to replace it with a proximity sensor. I hope you know the working of a proximity sensor. I discussed proximity sensor in detail in this video. You should watch that. This one is positive, this side is negative, and this side is the signal which is going to the K2 relay. And one thing is that these proximities will sense the A1 position. So now let's see in the fluid sim software. So I have my previous circuit. I just have to change this part. I need a proximity sensor. I have 4 proximity sensor. I'm going to choose this capacitive proximity sensor. You can choose any of them. And this proximity will sense the A1 position. Okay, now let's simulate. Let's go step by step. Pressing the PB1. K1 is closed, Y1 is energizing, the cylinder will extend. Okay. In A1 position, this proximity sensor will sense that and give a signal through this K2 coil. K2 energizes, this K2 will get closed, this Y2 energizes, the right side of this PCB will actuate and the cylinder will retract. See, it is happening. Let's see in the full automation. Pressing. Okay, it's working perfectly. Now let's see the other way. I will copy this circuit. Okay, now I have to give a proximity switch. I'll give a proximity switch here. Positive, negative, and watch this carefully. This proximity sensor will energize another relay. Suppose this relay is K2. So when this relay K2 energizes, then it will send a signal to this switch. So I have to make this a limit switch, which is not physically at the cylinder side. So it will just sense K2. And that's it. That's the solution. When K2 energizes, this switch is open and the circuit becomes deactivated. And after that, due to the spring return action, the cylinder will attain its initial position. Let's see in the fluid sim software. This limit switch will sense K2. I have to identify this as K1. Okay, so let's start. Pressing the PB1. See, K1 is latched, K1 is energizing, Y1 is also energizing, and the cylinder is extending. And at the extended position, this proximity sensor will sense that it is giving signal to K2, and this K2 will then open. See, this K2 is open, and this whole circuit gets deactivated. And for this spring return action, the cylinder will retract. See, now let's see in the normal speed. Pressing. See, it's working perfectly. So that's all for the solution. I technically explained a solution of 3 problems. We have many concepts in this video. We have latching concept, dominant off concept. Also, we used a proximity sensor in this problem. So if you have any confusion, please watch this video again thoroughly. And if still there is confusion, write in the comment. I'll make sure to reply. That's all for today. See you in the next video. Allah Hafiz.